Hello and welcome to this tutorial about how to generate font atlases for use with EasyGUI's integrated text feature called sprite text. There are two different free third-party applications that you can use to generate your font atlases. One is known as Hero, and it is cross-platform. It's written in Java, supports both Mac and Windows. And the second is Angel Code's bitmap font generator, and that one is Windows only. And you can visit the links on your screen there to use each one of those. The first one I'm going to show you is Hero, and here we have Hero up. The first thing we need to do is choose a font. We've got a list of all the fonts installed in our system. We can also fill in the file field and choose an actual font file if it's not installed in our system. The second thing we want to do is choose our size, and this is given in pixels, and this will affect how large the font will appear on the screen. So you want to make sure that you choose a size that's large enough for the largest use case you're going to have for this font in your game. Next thing we want to do is choose a character set, and we can actually type in whatever characters we want to be included here. And by the way, be sure not to forget to include the space character. Or we can choose from a preset list of characters. This is the full list of ASCII characters, or we can do the traditional Nihi character set used in the various Nihi tutorials. Next, we'll choose effects, and by default you have a color effect, and this is basically just the base color that's going to be applied to the text. It's a good idea generally to use white if you're going to want to use this font in a variety of color shades, so that you can actually use the color setting either in the editor or at runtime to alter the color of the font in case you want to shade it. But if you want it really stylized, you can add effects and other colors here and make it look really interesting. So for example, we can add a gradient effect. We'll choose a color and a second color. And then we can also add an outline or a drop shadow, a couple of different things here. And also remember, since we're exporting this to a texture, you can post-process this however you like. Just make sure if you're going to do some post-processing like adding an outline or drop shadows that you add a little bit of padding onto the edges. That'll give you space around each character so that you can add whatever additional effects you want to add without running the risk of graphics from one character bleeding over onto the other. The next thing we want to do is select the glyph cache radio button, and you'll see it's trying to cram all of our characters into these little bitty textures. And if you'll notice here, it's actually going to use 15 pages of these tiny little textures, and that's because each texture is set to 64 by 64 pixels. Now we can't really use it that way, so what we want to do is set the texture size to something that can hold everything that we want it to hold. So in our case we've set it to 256 by 256, and you can see that we're only using one page now, and you can verify that here. And that's what we want. We want to have one single texture. And also remember that if you're going to be doing this for iPhone and you want to use compression, the compression for iPhone, PVRTC, requires that your textures be square for them to be able to be compressed. I don't typically recommend using PVRTC compression for text because it introduces a lot of compression artifacts, but just keep that in mind if you do decide that's what you want to do. Now in our case we fit this pretty well to our block of text, but if while I was messing around I had set one side to 512, you can see there's some extra space we want to get rid of, so it'd be a good idea for me to drop things down to get it back to where I'm not wasting any texture space. Now once we have this the way we want it, all we have to do is export the font atlas as well as the font definition. And we do that by clicking on File and choosing Save Beam Font Files. And this says text, but what this is really going to do is it's going to save the a text file which tells where the individual characters are located on the atlas, as well as the atlas graphic itself. So let's go ahead and choose this option, and we'll give it a name. And since this font is called Laugh Riot, we'll call it Laugh Riot. Save. Now if we open the folder where we saved the files, we'll find a .fnt file, which is the font definition, and the PNG file, which actually contains the bitmapped content of our font. Now, for Unity to recognize the font definition file as a text asset, which is what we want, we're going to rename its extension to txt. Now, one more quick note before we proceed. In some situations, the font atlas output by Hero will actually be inverted. As you can see here, it's given me a texture that's completely upside down. So you want to look at your atlas and see if that's the case. If that happens, then what you want to do is flip it vertically or mirror it vertically using a paint program. So I'm going to use GIMP, which is again a free application. You'll find it at gimp.org. I'm going to open the graphic, and I'm just going to flip it vertically and resave it. And that's it. We're now ready to drag these files into our Unity project. But before we do that, let's go ahead and cover how to use Angel Code Bitmap Font Generator for Windows. Here we have the Bitmapped Font Generator application open in Windows. And the first thing we're going to do is click Options and then go to Font Settings. This is where we choose our font. So we'll just pick one that's installed. And then just like in Hero, we can set our font size in pixels. And then we can also choose font smoothing or bold or italic and settings like that. For more information about some of these other settings, you can see the documentation that comes with Angel Code Bitmap Font Generator. But this looks pretty good, so we're going to hit OK. And you can see here it's displaying for us the characters that are available in this font. So what we can do is either select individual characters by just clicking and dragging over them, kind of like painting in the characters we want. Or we can select an entire character set by checking it off here on the right hand side. But for games, I generally recommend, just like in Hero, hand-picking which characters you want to include. And that way you can really optimize your texture usage. You don't waste any memory storing image data for characters that you're not going to use in your game. Another way to do this is to click Edit and select Characters from File. And this lets you specify a text file, and it'll include any characters that are contained in that text file. So that's kind of similar to how Hero works, where you have the little text box that you type into. But now that we've chosen our characters that we want to appear in the atlas, we click Options and Export Options. And just like in Hero, we can add padding around each character to allow us to do things in Photoshop to add effects or halos or drop shadows around each character. And then we choose the width and height of our atlas. And just like in Hero, that's going to determine whether all of our characters can fit onto one texture or not. We always want to choose a bit depth of 32 because that will let us have alpha information so we can have transparent areas of our characters. And then I recommend choosing a preset that matches what you're looking for. You can play with these and see what works best for your case. And be sure to see the documentation included with the bitmapped font generator for an explanation of these different presets. But like I mentioned earlier, it's generally a good idea to use white text since it can be colored later. So we'll choose the white text with alpha. We want the font descriptor to be in text format. We want to use PNG for our actual texture because it's a lossless compression format. And that's about it. Now to see if we set the size of our atlas correctly, we can go to Options and Visualize, or just hit the V key. And here we can see what our atlas is going to look like. And you can see we've got some unused space down here, so it looks like we can probably reduce the size of this atlas to get it more optimized. So we'll just set the height to 128 and visualize that, and that looks pretty good. So now we're ready to actually export the atlas. So we'll click Options, save bitmap font as, and we'll call this font Stencil. And then if we open up the folder, you can see that just like Hero, it has generated a .fnt file. And again, we need to rename this to txt. And now we're ready to move these into our Unity project folder. So here we have an empty Unity project with nothing in it but EasyGUI. And we'll bring our folder over here that contains the two files that we generated using Hero. And we'll just drag these into our font folder. And you'll see here that EasyGUI comes with a sample font with it, as well as material for that font. So what we'll do is we'll just duplicate that material, and we'll call it Laugh Riot Font Material. And we'll tell it to use the texture for that font. And now we are ready to start creating sprite text objects. So if we want to create a sprite text object directly, we can just create an empty game object and then either drag a sprite text component directly onto this game object, or we can go to the component menu and go to EasyGUI Controls and choose the label. And the label is just another term in EasyGUI for a sprite text. The only two things we really need to fill in with the sprite text are the font, and we'll choose the font definition file, or we could have just dragged it directly on like this, and a material. So we'll expand the materials array in the mesh renderer component and choose our Laugh Riot font material. And let's go ahead and check the pixel perfect box so that we can get our results immediately, and it'll be sized to fit automatically. And we'll press play briefly, and there it is. And we can move it around. We can change the text here in edit mode, and there we have it. And you also find that there are other settings like the anchor and alignment that are basically identical to the same settings on the text mesh that you're all familiar with. One other neat thing is you can set a max width. Now this is the actual width in local space units, not the width in characters. And if this is set to 0, then the text content of this object will not be word wrapped. But if we set the max width to something other than 0, you can see here that it starts word wrapping the content to fit. So if we set it to something like this, then we can start typing. And you'll see that it automatically gets wrapped. And then we can change the alignment, and you can see how that affects the appearance. But let's say instead of creating a sprite text object directly, we just want to create a label onto an existing control, like a button. So here we have a simple button, and as you can see, it doesn't have any text associated with it. So what we want to be able to do is just type right in here to the button's text field, and it will automatically generate the sprite text to go with the button. But we can't do that just yet, because if we do this, it'll attempt to create the sprite text object, but it won't know what font and such to use, so it won't actually be able to do much with it. So what we first will do is we'll create another empty game object, and this is going to be our UI manager. And we'll add the UI manager component. Then we'll set up the default font and the default font material. Now I went ahead and imported our stencil font that we made using the Angel Code bitmap font creator, and we can just assign these to these fields. And now if I go back to our button and start typing in here, you'll see that it has generated a sprite text, that it has made a child of the button. And if we press play briefly, you'll see the text appear, and there it is. Now a couple more cool things to note. We can select the text component itself, and we can change the color to what we want it to be. And then additionally, sprite text allows you to actually insert color tags into the text itself that will color the text on a per character basis if you want it to. The way it works is you insert a color tag in the text, and it will color every character that follows it to that color. So for example, if we go ahead and add a color tag here, and this is specified in hex. If you've done any colors in HTML, you'll be familiar with this. So let's just make this red, so that'd be FF0000. We can also add an additional alpha component if we want to, with two more. So we can do FF, or if we wanted it to be translucent, for instance, we could do 77. And as you can see, that makes it translucent, but we want it to be fully opaque, so we'll set that back. If we omit the alpha component, it assumes opaque or full alpha. But as you can see, that makes every character that follows red. And now if we insert another color tag, and let's do this time, let's make it blue. So we'll do 0000 FF, and then type some text after that. And you'll see that the text that follows the blue tag is blue. Now if we removed the blue color tag, then only the red tag has effect. So that kind of shows you how the tags work. Also, if we were to put the red tag in the middle here, you'll see that the first part of the text takes on the color that we assigned in the actual sprite text component here, and the rest of the text is colored by this tag. So text that does not follow a tag will assume the color of the sprite text component itself, and after the tag, the text will assume the color of the immediately preceding tag. Now be careful not to get confused here, because we also have a color member here in the button, and that colors the button. So if we were to change that, that actually changes the color of the button, not the text. If we want to change the color of the text, we can either use a tag like that, or we can set the color in the actual sprite text component that's a child of the button. Let's cover a few more of the inspector settings of the sprite text object. You'll notice this is set to pixel perfect, and that means that the text itself is going to display at a 1-to-1 ratio of texture pixel to screen pixel. So let's say if the characters are 32 pixels high, then they will actually occupy 32 pixels on the screen. So they'll be sized in the game world to whatever size is necessary to occupy that many pixels on the screen. And you'll see that reflected in the character size. So this is how big these characters have to be in world units to have a 1-to-1 screen pixel correlation. Now if we turn pixel perfect off, we can adjust the character size directly. That is setting the actual size of each character in world space. So if we set that to 1, that is saying that a full height character, that is a character that goes from the baseline to the top, such as one of these uppercase letters, is going to occupy 1 unit of world space. Now the offset Z is how far along the Z-axis the text will be offset from the actual center point of the game object. So here we have a game object that's at 0, 0, 0, but these actual quads that make up the individual letters are offset by -0.1 on the Z-axis. And the reason you'll want to use that is so that you don't have depth fighting between your text and whatever the text is sitting on. So I'll show you what I mean. If I slide the text backwards a little bit, you'll see it eventually gets covered up by the control. So that's a useful thing, and that defaults to -0.1. Another important setting is the line spacing. This defaults to 1.1. That means that 10% of the height of a line will be put between two lines if this is a multi-line string of text. So if I were to set this to 1, then if I have multiple lines of text, those lines would be right immediately next to each other. So if I have some lowercase letters in the top line and some uppercase letters in the bottom line, they could conceivably touch one another or be exactly adjacent to one another. But if I put this extra little 10% or this 0.1, then that puts a little bit of extra space between the lines, and that's generally a good idea. The tab size, that is if your text contains a tab character, how many spaces it will insert for that tab character. So if you have 2 tab characters and this is set to 4, then it'll expand those tab characters to 4 spaces each, so a total of 8 spaces. We already covered max width. Dynamic length, that's really for future use. It's not really used internally yet, but this may be used more in the future for optimizing how large chunks of text are handled. You can't read this very well, I'll have to scoot this over, but this says remove unsupported characters, and that means, if you'll recall, when we created our font atlas, we only chose certain characters. So if this is in a text field or something, and the user inputs unsupported characters, they'll be removed from this object, so you don't have to worry about weird spaces or things showing up in your text. This is an option to parse the color tags. If we turn that off and then we hit play just so it resets itself, then you'll actually see the color code that we put in there. Now you're not seeing the hash mark or the brackets because those aren't part of our font, so it's ignoring those. But this is useful for, let's say, if you have a user profile text entry box where they're going to type in their username or something like that, and you don't want them accidentally entering color codes that are going to confuse them because what they're typing is suddenly going to disappear once it gets recognized as a color code, and it's going to color their name and all kinds of weird stuff. It can be cool to enable color tag parsing for something like a chat box in your game, but I wouldn't recommend it for something like a player profile, so you want to uncheck that in cases such as that. And of course we have our render camera. That's the camera that is going to be used to render the text. That's very much like the same setting in our Easy GUI controls and SM2 sprites. The hidden setting, if that is set, then by default the text is hidden at the start. And then finally the persistent checkbox, you'll want to check that if this object is going to exist between scene loads. So if you don't want this to be destroyed when you load a new scene, then you check that box and it will persist. Now I'm going to briefly discuss a couple of these script-related issues using text, either directly on a sprite text object or through a control. Here we have an empty JavaScript script, and I'm just going to declare a public variable that'll point to our button. I'll create a empty object to hold this, and I'll just call this the UI controller, and we'll drag the script on, and we'll populate the reference to our button by just dragging the button onto it. And now back in our script, we'll define a start function, and in the start we'll assign different text to our button, and we will use the text property. And note the uppercase T. Anytime you want to assign text to a button, or a sprite text for that matter, use the text property with an uppercase T, and we'll just assign it a basic string. And now if we hit play, you'll see the content was changed. And likewise, if we want this to directly reference the sprite text, we could change this variable to reference that. And save it. And then in this case we would drag this child object, which is the actual holder of the sprite text object. Now if we hit play, we see once again the text gets modified at start. So this shows you that both sprite text and Easy GUI controls have their text modified by assigning to their text property with a capital T. And finally, I'll show you one other way that you can insert colors to a string. So in addition to using the text tags that I showed you earlier, you can also do this. And then we hit play, and you can see the color red was inserted before the text that followed it. So when you're doing this in code, you can actually just add a color in to the string like this. And that concludes this tutorial about how to use sprite text.